and welcome back to the MCNA series. This is episode 5, and in this episode, we're going to have a new set of requirements, and it's probably going to be my favorite episode ever because it involves SD-WAN. You guys know me as the SD-WAN guy. I've spent the last 6 years designing and deploying SD-WAN all around the world. Most recently, the last 3 years, I was with Viptela and Cisco designing and deploying their solution, but I love all solutions of SD-WAN. There's all sorts of good ones out there. And the one we're going to look at today is one of my favorite. Maybe don't tell anybody. It might be my favorite solution. So let's take a look at the requirements. Dana Systems is growing so fast. We're acquiring a company. We're acquiring another app, actually. This app is called Kinder. What Kinder does is it's a playdate match app for the parents of kids. So if parents are looking for other parents and kids where they can put them together and have a playdate, well, they can build a profile and see the kids' different interests and what they look like and all that stuff, and they can make a decision to swipe left or right to see if that would be a good match for their kids to play with. So that's kind of a cool idea. I just came up with it right now, and I gave it a name. I had to give it a name that didn't sound, or it wasn't a trademark name, so it's called Kinder. I hope that's not trademark. Anyways, we have to integrate Kinder's existing SD-WAN solution, and it's Silver Peak. They selected Silver Peak and they deployed it enterprise-wide, and we need to connect their Silver Peak enterprise network into the Aviatrix cloud enterprise network. So that's our goal for today. It's going to be a ton of fun, and actually on the Aviatrix side, it's super straightforward, super simple, and the most of the work we're going to be done is actually going to be done on the Silver Peak side, but it's still fun to play with. So let's get started. So before we get started configuring anything, let's just take a look at what we're trying to accomplish from an architectural perspective. We're going to be working in the access layer of the multi-cloud network architecture again this week. There's so many things you can do in the access layer. I have a couple other use cases we're going to be able to play with in the future, but in this case, we're trying to connect in an existing SD-WAN fabric from Silver Peak and connect that into the cloud environment, and we're going to connect that, of course, to the Aviatrix transits so that we have visibility and control and additional networking functionality and anything else that we bring down the line, like the segmentation functionality. All that will be supported when you're having SD-WAN ingress and egress to the cloud. And so really what's going to happen, the way we're going to do this is we're going to build out a VPC that's dedicated as a transit VPC for SD-WAN. And so we build it out, we're going to call it Silver Peak SD-WAN VPC, and place 2 virtual edge connects inside that VPC. And those virtual edge connects are Silver Peak's SD-WAN routers, and they're going to build the WAN fabric, the SD-WAN fabric southbound to a bunch of remote branches, okay? But in this case, I only have one branch, 10.26.0.0/16, that's running an SD-WAN edge connect as well, and they're going to build a nice little fabric so they can talk to each other. I'll place a PC in there as well so we can test from that branch, so we can have end-to-end connectivity testing. Now, northbound, we have to connect to the Aviatrix environment, and we want to connect to both AWS West and AWS East so that we have the most optimal and efficient path to the workloads, appropriate workloads that we're trying to reach. And so it's actually pretty straightforward on the Aviatrix side. You just build some site-to-cloud tunnels, and then on the SD-WAN side, we have to configure that. It's a little more complex. However, it's quite nice. It's really fun to build out and watch it do its thing. So let's go a little bit deeper into what this SD-WAN pod looks like from a subnetting perspective, from a networking perspective, really what's happening within here. So let's look at my other Lucid. And you can see I've just blown that up, made it a little bit bigger and got a little bit deeper. And so this box, this lower box here, is the SD-WAN transit VPC that we're going to be concentrating on, and there's 2 edge connects in that VPC, 1 in each availability zone. And let's just focus on availability zone A for now, because it's the same thing in availability zone B, it's just duplicated. So in availability zone A, we have the edge connect, and there are 2 interfaces on the edge connect. There's a management interface, and then there's a WAN interface. They're both connected to public subnets. So off the WAN side, we're going to build the SD-WAN fabric. We're also going to build a full mesh of IPsec tunnels to 4 different gateways in the Aviatrix network. So we have AWS West Transit setup and AWS East Transit setup. That's already existing. We've been using that already. And as you know, we have an active architecture in those transits. We have the primary gateway and an HA gateway in both of those different transit networks. They're in different availability zones, of course, for a nice architecture. We're going to build IPsec tunnels to those, and we're going to run BGP across all of them. So we're going to have a really nice full mesh of tunnels for HA and ECMP and high availability and all that stuff, okay? So let's have some fun. Let's actually configure this now. Now I've built out most of this already because, you know, I don't need to spend time showing you how to build VPCs and subnets. You guys know that. I'll give you a quick look at what it looks like, and then we'll start configuring things. Okay, so let's just do a quick rundown of how I have it set up in AWS. So let's search by silver. We have two different VPCs in this region. I have branch 1 and transit. Now branch 1, don't worry about that. That's in the Lucid. That's this branch down here. I'm simulating a on-prem branch site with a subnet of 10.26.00/16. Don't worry about that for now. We'll come to that later. What we care about right now is transit and how that's set up. So the transit is 10.25.00/16. That's my CIDR for that transit. Now let's just scroll down a little bit and see what route table looks like for that particular environment. So if we go to routes, this is the route table that's connected to that environment. And I really have only two routes, the local 10.25.00/16. Then I have a default route pointing at an IGW to go out to the internet. Now you could build tunnels over Direct Connect, Express Route, and everything like that. We're just going to focus on an internet-based SD-WAN. Makes life easy. So let's take a look at the subnets for this environment. So let's type Silver Peak. So you can see I have we're going to focus on these four. I have 4 subnets. I have 2 managements and 2 WANs. Why? Well, we have 1 management and 1 WAN for the A availability zone and 1 for the B availability zone because they're connected to 2 different EC instances, right? The Edge Connect instances. I want to have high availability from a regional perspective, from availability zone perspective. So you can see the different subnets. I have 10.25.1.0. That's my Silver Peak management subnet for the primary box. And I have 10.25.2.0, which is the WAN subnet for my primary box. And then we have 4 and 5. Those are my secondary subnets. So it's pretty straightforward, easy networking. Let's also take a look at what I did in Silver Peak. Now, I've already deployed an orchestrator. This should have already been done by an organization if they have an existing SD-WAN fabric. And I have 3 different Edge Connect boxes deployed. I have 2 transits and I have the branch. Now, if we take a look at the transit, let's go look at its interfaces real quick so you can see what it looks like. I have basically the ones I'm caring about here is the management 0. That's going to be up and running. And I also have WAN 0. And look at WAN 0. It actually knows what its public IP is from AWS. It's able to gather this. The orchestrator will be able to tell him what his public IP is. And so he's got a private IP and a public IP. It's the same thing for the transit, number 2. Just a different public IP and different private IP, of course. And I have my branch set up. Now, branch is a little bit different. Branch has a WAN management and a LAN, because the LAN side is where I'm going to place my workloads, my PC. And so traffic is going to ingress the LAN. Now, it's going to get a little more complicated with what this looks like and how this is built out to get the tunnels correctly and all the routing correct. It's really not too hard. Once you get a hang of it, you kind of understand what's going on. But I'm going to walk us through it so that we all know we're all on the same page as I build it out. I also have the SD-WAN fabric pre-built. So branch 1 is already connected full mesh to Edge Connect 1 and Edge Connect 2, which are acting as sort of like hubs in that topology. So this video is not about building out SD-WAN from Silver Peak. You can go watch a million other videos from them on how to do that. It's actually quite straightforward. This is more about the integration between SD-WAN and Aviatrix. The first step here is to build out the site-to-cloud tunnels from the Aviatrix transit environments down to the Edge Connects. And so we're going to build these site-to-cloud tunnels from both the west and the east AWS transits. So let's get started. To do that, you go down to the transit workflow. You guys should be used to this if you watched my other videos. Click Setup. And step number 3 allows us to build those site-to-cloud tunnels with BGP on top. And that's this external device option. So you click External Device, BGP. We're going to select the AWS West. So we'll start with West. And we'll call it West Transit to Silver Peak. How's that sound? It's pretty long, but it makes sense. Okay, so 65009 is my AS, my local AS on that transit environment, and double check that I have a document. Let's see, 65009, yep, for West. And then, yes, it's going to be the West Transit Gateway. And we do want to enable HA because we're going to connect to two routers downstream, the two Edge Connect gateways. So yes, we want that to generate the second tunnel information for us. We don't need to manipulate the algorithms unless you really wanted to change some parameters for IKE and IPsec, but I'm going to leave them default. And then the destination remote is 65015. That's the AS for the SD-WAN environment. Now we also need to now get the IPs, public IPs of what we're connecting to. So I have the public IP here for Edge Connect 1, and we're going to pick Dana 123 Dana as a pre-shared key. You could just let it generate a really complex pre-shared key if you wanted to, but I like making my life easy and use simple stuff. Not very secure, but this is a lab, so whatever. And then I'll let it auto-generate the tunnel IP information, and we got to do the same thing for the other SD-WAN box. It's going to use the same AS, of course, and then we will select the secondary public IP right there, Dana 123 Dana, and that's it. We'll hit connect. Now you could enable segmentation here. If you wanted these IPsec tunnels to terminate on a specific segment that then gets carried into an AWS Transit Gateway route domain, which we'll talk about down the line in a different video, you could do that. So it's pretty cool. You can enable segmentation here. And there's a couple other ways you can do segmentation with Aviatrix, but let's just do no segmentation, a simple any-to-any connectivity model, and hit connect. Yes, I do want to create that, of course. So I'll pause it and it'll be back in a couple seconds. All right, and it's done. Great. So we're going to build another one now, and it's going to be from the east side. So we'll call that East Transit to Silver Peak. And I know my AS over there, 65003. Yes, it's the East. Yes, we want to enable Gateway HA. And everything else can stay the same because nothing else is changing from the Edge Connect perspective. So all this is good. 65015, 65015, the public IPs. All good, my pre-shared key. All right, hit connect. And it's done. And literally, that is all you need to do from the Aviatrix side. All the routing, all the BGP, all the IPsec, all the propagation of routes end-to-end will be done for you. That is it in Aviatrix. Everything else now is done on the SD-WAN side. Doesn't matter what SD-WAN provider you're using, Silver Peak, Versa, VeloCloud, Viptela, Cisco, whatever, it's all going to be the same thing, same process on our side. Pretty awesome, right? So let's jump into Silver Peak and start building this out. This is kind of where we get to have a little bit of fun. It's a little complex. We'll walk through it. I'll be slow so you guys understand what we're doing. But really, if you're a networking guy, it's not that bad. Let's get started. Oh, before I jump over there, you can see these tunnels that I just built by going to the Site to Cloud section down here. Scroll down. You can see I have two of them that were built out. The West Transit to Silver Peak and the East Transit to Silver Peak. Now to make our lives easy, let's grab the auto-generated configuration information so I can use those to reference when I'm building out my Silver Peak side. So I'm just going to click generic and I'll click download config. You'll see it downloaded two of them because there's going to be information for two different edge connects. Okay, now we do the same thing. Let's go back to the East one and do the same thing over there. Generic. Download configuration. Great. So now I got four configs for config information. Really what I'm going to do is I'm going to extract some of this information and put it into my own doc to make my life easier when I'm looking at things. But you'll get the idea of what I'm doing here in a moment. But if you take a look at one of these, you can just see all the information, the pre-shared key, the IPsec parameters, the DPD information, and also the public-private IPs, the tunnel IPs, the AS numbers, like pretty much everything you need to build it out on the third-party side, which is Silver Peak in this case. Again, I'm going to take some of this information to clean it up because there's just too much crap in here. I'm going to take it out and put it in my own doc to make my life easier when building the Silver Peak side. So give me a second and I'll get that done. All right, so let's get started on the Silver Peak side. Now I made myself a little cheat sheet with IPs, public, private, tunnel IP information, BGP, just so I can have a quick reference. Also, I know all the IPsec and IKE stuff by heart, so I'll go through that kind of quickly. Also, we have two ECs. What we do on one EC, we got to do on the second EC for the most part. There's a couple differences here from a BGP perspective, from a routing policy that I'll go into. But I'm going to build it all out in EC1, and EC2 is kind of pretty much the same thing, so I won't show you that. I'll spare you that, okay? So EC1, first thing we do is we're going to go to the tunnels section. That's under configuration and tunnels. Should bring up this page. And you should have all these pre-built tunnels that are just the factory default tunnels. So forget about those, they're not important. So click one of these little pencil icons so we can edit the tunnels. And then we're going to click pass-through. A pass-through tunnel is just basically a third-party IPsec tunnel. Okay, so we're going to build one of those. And we're going to click add tunnel. And then we're going to give it an alias, a name, so when we're looking at it, we know what the heck this tunnel is about. So we're going to call this Aviatrix Gateway West. Okay, so that's what we're building, building the tunnel from this EC1 to the Aviatrix Gateway in the west, the primary gateway. We're going to create an HA tunnel as well. So let's click IPsec, and yes, admin is up. The local IP is the WAN IP because we're building this off of the WAN, so 10.25.232. And I can just double check that by looking at my cheat sheet, 10.25.2.32. There it is. Okay, great. And then the remote IP is the public IP of the West Gateway. So let's go find that right here. So let's take that, throw it in there. No, we're not doing any of that. We can leave that alone. And we can add in a service name here. What this is for is later on you can build policy to punt traffic to this particular service. So let's just call it Aviatrix West. Okay, great. Leave everything else default. Let's go to Ike. Now I know my pre-shared key is Dana123 Dana. That's why I pick it, because it's so easy. And then we're going to use SHA-2 256, and we're going to select AES 256, and then Diffie-Hellman group is going to be 14. And then we're going to move this to 480 because that's what it is on the Aviatrix side, and it can't be changed. And the DPD is 10 and 3. We can leave that alone. Can't change that. And then the Ike identifier is going to be the public IP of this EC2 instance, EC1 instance. So let's call it, it's going to be this public IP right here. So let's grab that, throw that guy in there, and everything else can be left by default here. So IPsec now. We're going to pick SHA-2 256. We're going to do AES 256. We turn off the anti-replay because it's not supported right now. And then we're going to move this to 60 minutes because that's what it is on the Aviatrix side. And we'll use Diffie-Hellman group 14. Simple as that. Hit save and give it a second. Let's close it out. If I refresh this page, it should come up. There we go. It's up. So if you see right here, Aviatrix Gateway West, it's up. Now we got to replicate this for the other 3 gateways, right? The HA gateway in the west, the primary gateway in the east, and the HA gateway in the east. So let's do that real quick. I'm just going to pause the video. Well, actually, let me do the HA one because it's a little bit different. So let's create the HA one. So click the little pencil icon, and we're going to do pass through. We're going to click one of those guys. Oops, we're going to click add tunnel. And this guy's going to be called Aviatrix Gateway HA West. And then we're going to use IPsec. Local IP is the same thing, 232. The remote IP now is this guy over here. Okay, that's great. No NAT. We just call this Aviatrix West, the same service name. And then this is Dana123 Dana. We're going to do SHA-256, AES-256, Diffie-Hellman 14. This is going to be 480 minutes. 10 and 3 is good. And then my public IP of this buddy is this one again. Leave everything else default. The IPsec 256, disable that. This is going to be 60. Move Diffie-Hellman to 14, or the PFS, sorry, to 14. Hit save. Okay. Now that should be, if I hit close and refresh, it should come up momentarily. There we go. That one was quick. Okay, so now we got both of them up. Now I'm going to do the same thing for the east. So I'm going to pause the video, and I'll be right back, okay? And just like that, they're all done. So you can see them here. I have the Aviatrix Gateway West, Aviatrix Gateway HA West, Aviatrix Gateway East, and Aviatrix Gateway HA East. I have 4 tunnels that corresponds back to this Lucid chart. These 4 tunnels, 1, 2, 3, 4, all great. Now I'm just going to go and replicate the same thing on this side, 1, 2, 3, 4, but I'll spare it for you guys. It's the exact same thing, all right? So don't worry about that. Give me a second to go finish that. And at the snap of my fingers, all the tunnels are done. We have Aviatrix Gateway West, we have the HA West, the East, and the HA East. So all 4 tunnels are up. Now if we highlight all of these, both of these guys, you can see all the tunnels that are up. I like that. I like this UI. It's so nice, so easy to work with. The next step is to build VTI interfaces. This allows us to run BGP. So it allows us to apply a /30 subnet that can be routed logically across that tunnel so we can run BGP. So to do that, we go to configuration, We click VTI right there, virtual tunnel interfaces. And we're going to create 4 of them per edge connect. Now, if you go back to my cheat sheet here, you can see the 4 right here. So 4 here and 4 here. It's basically EC1 to West gateway, EC1 to West HA gateway, and so on. You guys get the idea. So I'm going to build a couple of these so you can see how it's done, and you can build out the rest on your own in your own lab, okay? So you click that thing, you go to this little edit icon. All right, great. We have no VTIs. Let's add some. Click add. Let's give it a name. We're going to do 100 through 103. That should give us 4 total, right? So let's do 100. And the IP mask, so it's the first one we're going to build is this guy right here, EC1 to the West gateway. So my IP is this guy, and it's a /30. And we now need to select which pass-through tunnel is this mapped to. We created those 4 tunnels before, right? So I'm going from EC1 to West gateway. So basically I want to do Aviatrix gateway West, okay? Now, LAN WAN, this is important. You need to make sure you specify LAN. To the Silver Peak SD-WAN fabric, all the routes coming from the AWS environment are going to be LAN routes because they're going to go into the SD-WAN on the southbound side of the network, okay? You can leave the label and zone alone. It's kind of advanced things if you want to play with zone-based firewall and other functionality, but leave it alone for now. So you don't need that. So hit add, and we're going to do the same thing for the next 4 or next 3. So 101, and this guy is going to be this one /30, and we're going to go to the HA West. Yes, LAN, good. Okay, we're going to add some more. 102, he's going to be this guy /30, and he's going to be the East. And we're going to add the last one, which is 103, and he is this guy right here /30. And he's going to be the HA, right? The last tunnel we have. Okay, good. Hit add, hit apply. Let's give them a second. Yep, they're all up. That was pretty quick. Now, what you want to do though is you want to test and make sure you can ping across each one of these so that you know you've done it right, okay? Now to do that, just right click on the Transit EC2, click Appliance Manager. This is how I do it. I'm sure there's another way you can do it. We're going to go to the actual appliance and ping from that appliance. Then you go to Maintenance, ping trace route. Okay, we're going to click ping, and then we're going to specify the destination, which is this guy right here. So we should be able to ping this. Yep, and we can. And you can totally tell that this is going across the WAN or going across, AWS, because look at the latency, 61 milliseconds. I actually have this EC2 built out in the east, and it's actually going to a west transit right now. When we do the east transit test connectivity, you'll see it's much lower because it's within the same AWS region. Okay, so let's check the other ones just to make sure everything's good. Ping. Oops, I gotta click ping. Yep, that guy's good. Test this one. He's good. So they can see, look, I'm going to the east now. So to east, look how low the latency is because it's within the same AWS region. How nice is that? Okay, let's check this last one to make sure connectivity is good. Bam, all done. So give me a second to go do the same thing on EC2. It's the same process. I'm not going to do that, spare you the time. So give me a moment, I'll be right back. And there they are. They're all up and running. All 8 tunnels, I can ping across all of them. Connectivity is ready. Let's move on to BGP. So to configure BGP, it's pretty straightforward. We're going to click Configuration, BGP, click the little edit icon, enable BGP, and it saved some information I had here from previous labbing, but you want to set an autonomous system number. I selected 65015 and a router ID 1.1.1.1 for me, for my lab, and leave graceful restart disabled. AS path propagate, you can enable or disable it depending on what your topology requires. You can go look into that to see what it does if you're curious. I don't feel like explaining it right now. So BGP peers, click add, and pretty straightforward. We just grab the information from my cheat sheet. So my first peer is this guy going to be here, the other side of the tunnel. And I want to select my VTI 100 because that's the VTI 100 tunnel I want to source it from. And the destination is, he's 65009 to the west. So I'm going to grab that. You can leave this branch. Some of these features you have to go look into on your own time what it's about because it'll just take too long to discuss. But leave the default branch is fine. Admin up. Next up self, you can leave that unchecked because that's for iBGP. And then one thing you got to make sure, you have to specify an inbound and an outbound route map. And we'll go into that in a second, but it's important to select that, otherwise the BGP does not come up. So let's just do the default inbound, and the for outbound, I pre-created one called primary out and secondary out. Basically, the primary out doesn't prepend any ASs. The secondary out will prepend the AS 3 times. And the reason I did that is because when you're building SD-WAN from Silver Peak and you're using WAN optimization, you want to make sure flows all go through the same box in and out so they can be optimized. Otherwise, you're going to have asymmetric flows. From a routing perspective, that's not bad, but if you're doing WAN op, that can be bad. So I created a policy, and I can show you that policy here. So basically, since this is a primary router, EC1, I'm just going to select this primary one. It's basically a copy of the default, but it doesn't have any prepending. Okay, so that's great. And I'm going to use 10 and 30 because that's what we use on our side for our keep alive and hold time. No password. We're not using that right now, and we're going to hit add. Okay, we're going to do the same thing for the other 4. Or the other 3, I should say. So this guy is this one. It's going to be, this time it's VTI 101. And the peer AS is 6509 still. Branch up, no XOP self. We can select these guys. Still a primary. 10 and 30. Add. Okay. And we have 2 more to do. The east side. So that's going to be this one. And it'll be 102. But east is 003. That's his AS. I remember that. So same drill. 10, 30, good to go. Add the last one. We're almost done. Select this guy. 103, 65003. Select the route maps. 10 and 30, add. Okay, apply. Now let's give it a second. It's got to actually bring up the BGP process. I like to click things a million times. It seems to make things go faster. No, it's just in my head. I just like clicking things a lot. And there we go. They're all established. And you even get a little soft reset button. I love that. You can click the little soft reset if you need to reset the route there. Okay, great. So everything's up on this side. I'm going to do the exact same thing for EC2 now. And again, I'll spare you that. I'll just do it for you. One thing to note here for EC2 is that you need to have a different router ID. Make sure you pick a different one. Also, for the secondary Edge Connect, if you're trying to keep things symmetric through the primary, we're going to have to prepend the AS outbound to the Aviatrix. So Aviatrix will select EC1 as the primary Edge Connect to send traffic to. Now, if you want to take a look at what that looks like, let's just click the little edit button. And then we're going to look at the secondary Aviatrix out EC2 one that I created. And you can see here that in the policy, under source protocol SD-WAN local static, so anything that the SD-WAN router is learning from an SD-WAN route from a different branch site over the SD-WAN that's local or static originated, then we want to prepend the AS 3 times. You can see what the policy looks like. It's so simple. You just click here and click 3. And that's going to prepend 65015 3 times. All right, so now everybody, all the neighbors on the other side will pick EC1 as the better path because it's got a lower AS path. All right, that's how simple that is. I really love this setup in Silver Peak. All right, and it's done. So if you look at all 8 should be done as well. Yep, they're all done across both ECs. All right, so the next step is to make sure that we're learning routes. So let's go back to just looking at one router for now and go to configuration and click routes. And we're going to be looking for routes 10.1, 10.2, 10.3, 10.4, and 10.5. All right, here they are right here off the top. 10.1, 10.2, 10.3, 10.4, and 10.5. Those are my cloud routes. Remember the cloud /16s I have running in AWS workloads? So those are from Spoke VPC siders coming down to the Aviatrix transit, then getting down into the SD-WAN transit, into the SD-WAN transit Edge Connects. Fantastic, awesome. 10.1, you can see here 10.1, 10.2, 10.3, 10.4, 10.5, and the next hop interfaces across the VTIs. Now, one thing to note is that today, Silver Peak doesn't support equal cost multipath routing, ECMP, on BGP. They're going to bring that feature really soon in a couple of weeks, but right now they don't support it. So you're going to just be sending traffic to a single gateway in each region. We'll be able to get that feature, they'll be able to get that feature for us later on. We support ECMP down towards them, however, so we can do ECMP in our active mesh architecture. We have something called active mesh, which allows us to do equal cost multipath active tunnels from both gateways, so you can higher throughput. So towards the edge connect, we'll be able to do equal cost. They just can't do it towards us. All right, so great. Now let's also double check to make sure that route made it to the branch. So we go to the branch site. We look at his routes. Doesn't look like it. I wonder why. Well, there's one thing we have to do in the policy. It's basically a redistribution policy to allow BGP to go into SD-WAN routing. To do that, under routes, just scroll to the bottom and click the little pen icon. And then we're going to manipulate or edit this redistribution route map, okay? So you can see right now, it's denying any route sourced from BGP from being advertised into SD-WAN. We need to change that. So we're going to edit that. And we're going to click permit. Okay, hit update, hit apply. Okay, we can close that out. Close that out. We need to do the same thing for EC2. So he also advertises his routes to the branch. Scroll down, click this dude. We're going to edit that guy. Change BGP to yes, do not deny it. I want to advertise BGP. Apply. And you can play with all sorts of filters in here if you want to get more granular. It gets pretty good. All right, exit those. Now if we go back to the branch, we should see those routes. Bam, there they are. And we're going to be doing equal cost multipath flow-based load sharing across two different edge connects from the branch. So from the branch, we have two peers, two hubs, EC1, EC2. So we can do flow-based load sharing across these two different hubs. Let's also take a look at the Aviatrix side to make sure that routing is set up correctly there. So to see that, we go to the dashboard. Under Transit Network, we click Advanced Config. Under there, we select the Diagnostics tab. And from here, we can select whichever gateway we want to run BGP commands on. So let's do West Transit. Let's just run a normal show IP BGP to see what BGP routes are being learned. There we go. I see 10.26.3.0/24. That's the route in question. That's our SD-WAN branch route that we're learning from EC1 and EC2. So you can see EC1 is .209, EC2 is .25. How do I know that? Well, EC1, which has the little arrow sign next to it, is the best path. Why is it the best path? Well, it's got the shorter AS path length. It's got 65015, whereas EC2 has 65015 prepended 3 additional times. If you remember, I created a policy in Silver Peak to prepend anything leaving EC2 3 times, prepend the AS 3 times, because I wanted traffic to always go into EC1. As an example, for when you were running WAN optimization, you want everything to run through the same box so that that box sees all the source and destination traffic to optimize the traffic. Now, if you're not doing WAN op, not doing TCP op or whatever it is on that box, then you can just let the routing happen naturally and let it pick the best path, and you don't have to worry about creating any policy to prepend and whatnot. But I just want to show an example of how to do that in case you do come across this in the real world. Let's take a look at the East Transit, same command. Yep, and it's picking EC1 as well. You can see it's got 1 AS in the path. Perfect. So at this point, we should be able to test our end-to-end traffic flow. I have a branch PC in the SD-WAN environment, and I'll try to ping, let's say I'll try to ping a branch in the Google Cloud. So if we go back and take a look at my Lucid chart, over here, I have a PC all the way down here in this branch, and I'll use it as my test point. I want to reach a resource all the way across AWS and into GCP. So the path of traffic will be from my branch through the SD-WAN, through the Silver Peak SD-WAN, into the SD-WAN ingress-egress pod, across there into one of the transits. I have to take a look at the routing path to see which one it would take, but it's going to go into one of these, and then from here it'll then go directly to GCP because I have a peering between GCP transit and the AWS transit. It's just not shown on this diagram. So let's take a look at that right now. So let's jump into that PC that's sitting in the SD-WAN branch site. You hit connect, go to its CLI, and what we're going to do is ping from the SD-WAN branch PC across the SD-WAN overlay into the SD-WAN ingress-egress pod, across the links to the Aviatrix ingress, transit ingress, then across the transit, global transit backbone to GCP and to the workload. So it should be nice. Ping 10.5.0.2, which is a workload in GCP. And there we go. It's going end to end. How fantastic is that? Now the latency is going to be a little bit high because, as you guys can imagine, it's got to cross all sorts of peerings and regions to get there. And it's going across different geographic regions as well. So it's a little bit higher latency. but that's expected. All right, awesome. So at this point, we've built out the connectivity end to end for this SD-WAN integration. If we just review it real quick, we've built this out, this whole pod out, and as well as the connectivity into SD-WAN. Now, what's great is that Aviatrix takes all the responsibility to control routing end to end for you. So the moment we learn all these routes via BGP from the pod, the SD-WAN pod, we will then program those routes across transits into VPCs, into TGWs, into GCP, into Azure, into all the route tables, pretty much end to end for you, and then we'll pull those routes if we needed to, if the route went away, for example. So we're managing these, we're watching these routes, we're acting as an SDN routing solution for you. This is just one of the use cases, one of the things the controller does, but it does it so brilliantly and saves you so much time. Imagine having to do this manually. It would take forever. And that's it. This is really all I wanted to show you in this episode, how easy it is to integrate any type of SD-WAN. In this scenario, we did Silver Peak, but it could be VeloCloud, it could be Versa, it could be Viptela, it could be whatever, any SD-WAN that supports IPsec tunnels to any third-party environment. It's really simple to set up, and I'm hoping that you guys enjoyed this one as much as I did. I'll see you next time.